Have you ever seen a homemade antenna built from a stainless steel mesh racket? If not, this is the perfect moment, because we're about to roll up our sleeves and make one right now. And the very first step, I'll cut off the handle of the stainless steel mesh racket. Not to toss it in the trash, of course. That piece will be saved for another video topic down the road. For this project, what we really want is the frame and the mesh head, because its structure looks remarkably like a satellite dish for TV signals. It's a perfect match, and honestly, that kind of coincidence always makes me smile. Next, I have a male power plug, and I'll be repurposing it to connect the signal collecting dish to the antenna base, forming a seamless joint. Instead of serving its original purpose, this familiar component will act as a mechanical connector. Using the metal prongs of this power plug, I'll connect them directly to the two metal terminals of the signal collecting dish, allowing the signal to pass through quickly, smoothly, and without interruption during operation. The antenna base for this setup is simply a power socket. Trust me, there's hardly a better option. It connects cleanly with the plug-in mesh assembly and also provides an easy connection to the coaxial cable feeding the TV. Simple, practical, and with almost no drawbacks. This is the coaxial cable I mentioned earlier. Its job is to carry the signal from the antenna's receiving section directly to the TV with minimal loss and interference. Thanks to its copper core and shielding layer, the signal travels quickly, cleanly, and without interruption. And right now, I'm temporarily connecting one end of this coaxial cable to the power socket, while the other end will be handled later in the next step. For the other end of the cable, I'll add a straight F connector and a 90-degree F connector, making it easier and cleaner to connect everything to the TV. Following the proper order, I'll install the straight F connector first, then attach the 90-degree F connector afterward. Alright, the homemade antenna is now complete. How well will it actually work? There's only one way to find out. Let's test it right now. But before connecting the homemade antenna to the TV, I'll do a quick check on this screen so you can clearly see that there's no signal at the moment. After that, we'll connect the DIY antenna and see what changes. That's impressive. It only took a few seconds for the TV to lock onto a broadcast signal. Still, to see whether it stays stable, we'll need to watch it for a little while longer. After monitoring it for a while, I didn't notice any issues. So I decided to unplug the connection and plug it back in to see whether the signal remains stable. It's great to see that nothing unusual happens at all. After multiple checks, unplugging and reconnecting the setup several times, the TV signal remains solid and consistent. No flickering, no dropouts, and the signal locks in just as quickly as it did from the start. For a homemade antenna built entirely from everyday items, that's a result that honestly exceeded my expectations. What I enjoy most about this project isn't just the performance but the idea behind it, taking ordinary objects and turning them into something that actually works in real life. No expensive equipment, no complicated tools, just a bit of observation, some trial and error, and the willingness to give it a shot. And that's really what DIY is all about. It doesn't have to be perfect, but every attempt teaches you something new. If you happen to have similar materials lying around at home, this might be a fun project to try for yourself. And for now, we can confidently say that this homemade antenna is capable of delivering stable, reliable performance.